Alright, so now we're going to look at how we can solve the problem using ODE 15S. In the last video I said ODE 45 really cannot do anything here because the domain length is really large, and so what MATLAB tries to do is to split the domain length into many subintervals to basically be able to resolve the fast decay reaction that we have, in one of those three differential equations. So anyways, this is not going to work. I'm going to comment this out, and I'm going to uncomment the ODE 15S. So I also solve it using RK4 that I have. Alright, so let's try this. So this piece should be inaccurate because this is RK, you see at this. So this is the solution from RK4, which is completely inaccurate, and you see that this piece is going to like 10 to the 300, which is completely incorrect. And if we remove this, you see that the exact solution is this blue line from ODE 15S. That was really actually quick. So we can actually delete it right here. So let me delete. There you go, you see that. Now the solution is in order of 10 to the 4, which makes sense. And if I delete this one, you see that the ODE 15S actually captures the right behavior. And there you go. So it's a periodic increase and decrease in the concentrations. And the values usually don't go beyond 10 to the 4. So this is much more accurate than ODE 45, even if you can get it, which I don't think that's the case. And ODE and RK4 does not even get, around this accuracy. So we cannot use ODE 45. And the best way is you do ODE 15S again. Okay, so that almost ends our discussion on stiff ODEs. So we talked about ODE 45 and 15S. So again, to recap, the first thing you may want to try is ODE 45. If the problem is a stiff and has time constants that varies in order of magnitude, in multiple orders of magnitude, then ODE 15 is, I think, the best shot. ODE 2-3 is usually if the accuracy is not important, but we want to solve things really fast. Okay, so I hope this is useful. Thanks all for watching. Stay tuned for the next video on boundary value problems.